So here we complete this question. Next question. Question 5C. Find the basis for the orthogonal complement of the subspace spanned by the vectors 2, -1, 1, 3, 0 and 1, 2, 0, 1, -2, 4, 3, 1, 5, -4, 3, 1, 2, -1, 1 and 2, -1, 2, -2, 3. You can see here we have total 5 vectors of R5, right? And what we have to find the basis for orthogonal complement of the subspace spanned by this 5 vectors of R5. So there is one important theorem which we will use here. First of all, W be the space spanned by this 5 vectors, right, is the same as the row space of the matrix, in which all the rows are this 5 vectors. The first row is from the first vector, the second row is from the second vector, and similarly the third, fourth and fifth vector. Now here we want to find basis for orthogonal complement of subspace spanned by this 5 vectors. So for that, there is one important theorem, that the null space of A is exactly the orthogonal complement of W. You can see by known theorem that the null space of A is the orthogonal complement of W. So definitely we have to find the null space of A, and for that again we have to convert this matrix into a row echelon form matrix. As I explain you that what is the meaning of row echelon form and how we convert any matrix into a row echelon form, that we already seen in some of the examples also in this question paper. So let's first of all try to convert this matrix into a row echelon form, and then using that row echelon form matrix we can find the null space of matrix A. So you can see this 5 vectors are now 5 rows of this matrix: first row, second row, third row, fourth row and fifth row. So 2, -1, 1, 3, 0. Second row is 1, 2, 0, 1, -2. Third row is 4, 3, 1, 5, -4. Fourth row is 3, 1, 2, -1, 1. And the fifth row is 2, -1, 2, -2, 3. Okay. Now we have to convert this matrix into a row echelon form. So that's why consider the homogeneous linear system Ax is equal to 0. We have 2, -1, 1, 3, 0, 1, 2, 0, 1, -2, 4, 3, 1, 5, -4, right, 3, 1, 2, -1, 1, 2, -1, 2, -2, 3. The first row is first process is R12. First of all we are interchanging first and second row, right, and all other rows are as it is. So here is the first operation, first process R12, we are interchanging first and second row. So now the first row is now 1, 2, 0, 1, -2, second row is 2, -1, 1, 3, 0, and third, fourth and fifth row are as it is. Now we are interchanging, now next process we are multiplying first row with -2. Now this is our leading entry. You can see this first one is our leading entry, and below that leading entry in that column we want 0. So that's why we are multiplying first row with -2 and add into the second row, also multiplying first row with -4 and add into the third row, first row with -3 multiplying -3 and add into the fourth row, and then multiplying with -2 and add into the fifth row. So first row is only as it is, the second row become 2, -2, 0, then -1, -4, -5, then 1, -0, 1, 3, -2, 1, 0, -4. So plus 4. So finally second row is now 0, minus 5, 1, 1, 4. Again we are multiplying first row with minus 2 and add into the third row. So the third row become, you can see, you can understand from this matrix, 4 minus 4 0, then 3 minus 8 minus 5, then 1 minus 0 1, then 5 minus 4 1, and then minus 4 into minus 2. So that is minus 4 plus 4 plus 8. So you will get 4. So you can see the third row is also 0, minus 5, 1, 1, 4. Now next when we multiplying first row with minus 3 and add into the fourth row. So the fourth row is now 3 minus 3 0, then 1 minus 6 minus 5, then 2 minus 0 2, then minus 1 minus 3 minus 4, and then minus 4 plus 6, sorry 1, this is 1 plus 6, you will get 7. Again when we multiplying first row with 5 with minus 2 and add into the fifth row, you will get 2 minus 2 0, right, minus 1 minus 4 minus 5, then 2 minus 0 2, then minus 2 minus 4, right, minus 2 minus 2, you will get minus 4, and then 3 plus 4, so again 7, right. Now you can see the second and third row are same, similarly fourth and fifth row are same. So next process is, now you can understand that when we multiplying second row with minus 1 and add into the third row, so the third row becomes 0. Similarly when we multiplying fourth row with minus 1 and add into the fifth row, so the fifth row is also 0. So here is the next process is, right. So third and fifth row is now 0. Now we are interchanging third and fourth row. So all the 0 rows are now bottom of the matrix. Okay, still you can see this is our leading entry, below that leading entry we have all the 0, and second row this is our leading entry, below that leading entry we won't make 0 here. So that's why we are multiplying second row with minus 1 and add into the third row. So the third row is now, you can see 0, then 2 minus 1 1, minus 4 minus 1 minus 5, and then 7 minus 4 3. So the third row is now 0 0 1 minus 5 3, 0 0 1 minus 5 3, right. First and second row are as it is, also fourth and fifth row are already 0 rows. So there are no changes in the first, second and fourth and fifth row, only change in the third row, right. Now you can see this matrix is now row echelon form matrix, and now using that row echelon form matrix we can find the null space of the matrix A, which is exactly our orthogonal complement of W. So to find null space, this is now row echelon form matrix, and using this row echelon form matrix we get these equations: x1 plus 2x2 plus x4 minus 2x5 is equal to 0, minus 5x2 plus x3 plus x4 plus 4x5 is equal to 0, and then x3 minus 5x4 plus 3x5 is equal to 0. Okay, now you can see first, second and third column we have leading entry, fourth and fifth column we don't have any leading entry. So that's why x4 is equal to, take x4 is equal to s and x5 is equal to t. So corresponding to these two values, the values of x4 and x5, you will get value of x3, that is 5s minus 3t, x2 that is 5s minus 3t minus s minus 40 divided by minus 5. So 4s by 5 plus 7t by 5 Now x1 is equal to minus 2x2 minus x4 plus 2x5, that is equal to minus 2 into 4s by 5 plus 7t divided by 5 minus s minus 2t, that is equal to minus 13s divided by 5 minus 24t divided by 5. So the null space of A, that is equal to minus 13 by 5, 4 by 5, 5, 1, 0 into s plus minus 24 by 5, 7 by 5 minus 3, 0, 1 into t. Hence basis for the null space are minus 13 by 5, 4 by 5, 5, 1, 0 and minus 24 by 5, 7 by 5 minus 3, 0, 1. Clear? So this question was complete. Now here this is exactly the basis for the null space of A, which is exactly the orthogonal basis for the orthogonal complement of W, which is spanned by this 5 vectors, which is given in the example. So next question, question 6a. Verify Cayley-Hamilton theorem for this matrix A. 6 minus 1 1 minus 2 5 minus 1 2 1 7, and hence find A raised to 4. Here is the solution. Now the characteristic equation for the given matrix A is lambda cube minus s1 lambda square plus s2 lambda minus determinant of A, that is equal to 0, where S1 is equal to sum of the diagonal entries, that is equal to 18. You can see sum of the diagonal entries, 6 plus 5, 11 plus 7, 18, right? S2 is sum of the minor of the diagonal entries, that is you can see the determinant is 5 minus 1, 1, 7. So that is 7 into 5 plus 1. So 35 plus 1, 36. Then minor of this 5, that is determinant 6, 1, 2, 7. So 6 into 7, 42 minus 2, so 40. So that's why plus 40, and minor of this 7, 6 into 5, right? Just remove this column and row. So finally we will get this 4 elements, 6 minus 1 minus 2, 5, 6 into 5, 30 minus 2. So 28. So addition of this 36, 40, 28, that is 104. Okay, 104. And this is not S3, this determinant of A, that is equal to 192. That you can easily find the determinant of A. I hope that you can understand that how to find determinant of this 3 cross 3 matrix. Okay. So determinant of A is 192, just check it. Now put all this value in this equation, you will get lambda cube minus 18 lambda square plus 104 lambda minus 192 I means identity matrix, that is equal to 0, right? Now here is not I, just 192 is equal to 0. Now Cayley-Hamilton theorem, what is the meaning of Cayley-Hamilton theorem? Cayley-Hamilton theorem says that every square matrix satisfied its characteristic equation. Every square matrix satisfied its characteristic equation. So characteristic equation is here lambda cube minus 18 lambda square plus 104 lambda minus 192, that is equal to 0. So now Cayley-Hamilton theorem says that every square matrix satisfied its characteristic equation. So we have to prove A cube minus 18A square plus 104A minus 192I, that is equal to 0. So that's why we have to find A square. We have already identity matrix, that is 1 0 0 0 1 0 0 0 1. A is already given in the statement, so that's why we have to find A square and A raised to 3. A square is this matrix. Yeah, we have to multiply this two matrices, 6 minus 1 1 minus 2 5 minus 1 2 1 7, right? So how we multiplying any two matrices? The condition is the number of column of the first matrix and the number of row of the second matrix both are same. It should be same. So here both the matrices are same size, so definitely we can multiply these two matrices. Now pick up the first row. I just want to explain the one element, that how we make this 40, right? How comes this 40? That multiplying first row of the, just pick up the first row of the first matrix, 6 minus 1 1, and multiplying with the first column of the second matrix. So 6 minus 1 1 in, right? So with each and every coordinate, so 6 into 6 36, plus minus 1 into minus 2 2, plus 1 into 2 2. So you will get 36 plus 2, so that is 40. Now similarly, when we multiplying first row with the second column of the second matrix, you will get minus 10, and then multiplying with third column you will get 14. Okay, now pick up the second row of the first matrix and multiplying with each column, and then pick up the third row and multiplying with each column of the second matrix. So finally you will get this all the elements of A square, right? Similarly we can find A cube, that is A square into A. This is exactly the value of A square, and this is A. So again we multiplying this two matrices easily, right, as I explain you. So also you can also use the scientific calci in your examination, so definitely you can easily multiplication of these all elements. So finally we have to check that A cube minus 18A square plus 104A minus 192 into identity matrix. Put all these values, A cube minus 18A square plus 104 into A minus 192 into identity matrix. So finally you will get this 0 matrix. It's quite easily just summation with each and every coordinates, right? 288 and plus 104 into 6. These two are positive values, and for the first coordinate, and the negative values are 18 into 40, 192 into 1. So when you addition of these two terms, both are